Hey guys, what's up? I haven't posted in a while. To sum things up real quick before we get too far into Maslow topics, because I'm super excited to talk about what I've been working on with this machine. I just like to kind of lay it out a little bit. When I was filming my last videos, first off, I had just kind of a basic idea of what I wanted to do. I just wanted to kind of shoot the machine in action and just kind of show what it could do. But I moved on from that pretty quickly to the point where I wanted to start getting into some more in-depth conversations about this, because I've been participating in development on this on the forums for quite some time now. And I feel like I can either help share some insights into what my development process has been here, and also just kind of cue everybody in and let them know, like, this is what I've been working on for the last year plus now. So yeah, I moved into this new place about back in July of last year, so a year and a month ago now. It has been quite a project to fix up. We're still in the middle of doing siding right now. I also did like an interior remodel because the original interior was disgusting. The carpet was so sad. We put new windows on the place, although that was more just a financial cost than anything else, as well as HVAC was pretty expensive, but you know, had to have an electrician in to even get the HVAC installed. So it was a lot of stuff building, and this summer I've really been focusing on trying to get my siding fixed, because we have a contractor coming in and actually installing the vinyl siding, but this building is just plywood basically. The entire exterior is just what's referred to as T111. It's kind of like a barn board looking thing. It's literally just like a half-inch piece of CDX plywood that they ripped dados into to make it look like it's a ribbed barn board or something. No weather barrier. Bugs are everywhere. I actually tore out part of the wall over in the garage where there had been so much termite damage that literally, like, the header and the 2x4s in that particular section of the wall had rotted through to the point where they weren't structural. So I turned that into a door, closed up the old door because it was binding. Is there anything else major? I mean, we still have to redo the bathroom. And then the other thing that's really been sucking up my time has been working on the plow truck for this property. More details on that later. So, without further ado, I'm going to get back into talking about the Maslow here. In particular, what I'm going to be focusing on is a pet project of mine that people in the community has definitely been helping out with. I've had a lot of really good feedback on it. I've had a lot of people contributing to it, which has been fantastic. And it seems like it's just a really popular upgrade now on the Maslow. And I'm going to kind of go into what my design decisions were with this, and kind of why I think it has become kind of a popular upgrade for it. So let's dive right on in. The stock Maslow uses a rigid router. This is what's the actual model number? It's the R2901. Actually, I'm not sure if this is the exact one that Bar recommends when he started the Kickstarter for this. This thing has been a workhorse. It's done a fantastic job for me. This is kind of dangerous, but I actually have my workhorse bit in it still from the last time I was running it. It's a little dull now. I can see it's discolored, but it does a really good job. It's a single flute because the machine's so slow that in order to get the ideal chip loads, I had to reduce it to only a single flute. This is actually intended for cutting plastic, but it does a phenomenal job with plywood. I cut all of my Meticulous Z-Axis with it. I've cut tons of other things. I've cut cabinets, couple of signs and such, you know, simple things. So this is kind of the core of the sled. That mounts and feeds through the center hole here, and it was originally using just the router base that comes with it. So this bolts to the sled like so. The router itself slides in and out, and there was a servo motor hooked up to our lead screw on the base here. Now, let's get into why this doesn't work particularly well for the Maslow's application. This was clearly only ever designed to be used as a depth stop when you're doing manual router operations. Now, I need to preface all of this by saying I'm not knocking the design on this at all. It was a low-cost design. It was intended to get people up and running, and on the most part, the majority of the Maslow community are all tinkerers and such, so we all love playing with this shit anyways. But yeah, this particular setup has a lot of what's referred to as backlash in it, where there's a lot of potential for movement in this. Some people have printed, like 3D printed plastic shims and such, or improved this coupler, because I think I remember hearing that if you bottom out this, which this is what holds this here, locks into this tab, and that's what's moving this up and down through this. And if you bottom this out, either at the top or bottom of this, it would actually shear plastic components in here, so they made more robust versions of that. The original solution to this backlash thing, instead of 3D printing components and such to modify this, was literally just to run a bungee cord over the whole thing and preload this router towards the workpiece. And that solved the backlash issues on the most part. I saw some Z-stepping on various things that I've been working on, so obviously it wasn't perfect. I could tell that it stuck a little bit, especially when it was transitioning to, when I was doing tabs at the bottom of a cut, and it would start moving with the tab, and then it would get to the point where it plunges back into the material, and this would move, but it would kind of like tilt a little bit, and it wouldn't be until you got some of the vibration of it moving, of the router actually moving with the side load, that it popped down and actually started cutting all the way through. Not a huge problem. My slots were just a little, or my tabs, sorry, were just a little bit longer than I had originally programmed them to be. What kind of ground my progress in the Maslow to a halt, though, was that as I ran this machine, I started to develop significant wear patterns on both the router body. You can see some of it here and along here, as well as all down in here, to the point where it started sticking. And I liberally applied silicone lubricants and such to the inside of this just to keep it from freezing up. But I think after a certain point you use it so much, and I'm sure that part of the problem is that sawdust all accumulates in here because it's a router. And actually you can see a bunch of that right up in here too, so maybe you can see that. So yeah, that binds up this whole assembly, and then what I was seeing was that my router would finish cutting a contour pass, a perimeter pass, and it would go to retract out of the material, and it would only get about 6 millimeters away from the top, so about a 1/4 inch for us American folks. It would stick, it would bind in this whole thing, and then it would drag that bit across the surface at a 1/4 inch depth. A bunch of the things that I was working on at that point ended up having this little curve through it, and they were functional things. They weren't like supposed to be aesthetically beautiful things, so I didn't care as much. But if I start working on a sign, I'm going to want this to be dead nuts precise. Alright, so the other thing I wanted to get into about the issues with the stock setup is that it had inadequate dust collection. So how this dust collection works on this particular setup is that the router is fully encased in here, so this is all closed in. There's actually a window that goes over here. It's somewhere in my pile. And then it all comes out through this dust port, which this little ring that I cut here is actually just an adapter to fit like a normal, that's a little loose, but on the hose it works much better. So that just seats right over that, so I could use a larger hose with my dust collector. That port is far too small for the kind of dust collection you need out of a CNC router. When I did my new design, I actually calculated out kind of the ideal flow rate and designed something that got pretty close to what it needs to be. It's not perfect. If/when I ever do another revision to the dust collection system, I'll resolve that because there are some potential flow issues. But when I do that, I'd like to put it through like SolidWorks and actually do flow simulation and all that good stuff to know exactly what I'm dealing with. So let's get into the Meticulous Z-Axis. This is where mine presently stands. I had started cutting this back last fall, I think it was, October I want to say. That doesn't sound right actually. I'm not sure when, but it was a while ago now. Let me just put it that way. I cut this all out of 3/4 birch ply. It's all good, high quality plywood, no voids. At least I'm pretty sure there are no voids. And this uses a lead screw and guide rails. All three of these are 8mm to drive the carriage up. And these are machined spindle clamps that fit perfectly to the rigid router, which I forgot to mount sideways like that. It fits. It's tight. It's a tight fit because it's machined. But this fits to this, and it centers the router on the sled. Specifically centers it on the linkage pattern. We'll get into that. This is the front end of my dust collection. The only thing it's missing is a clear acrylic window that I need to cut when I get this thing back up and running again. Because as I mentioned, the base got stripped out on me and started seizing, so I don't want to cut a clear acrylic cover for this thing and risk getting that all cut up. I want that to be nice and pretty because you guys are going to be watching YouTube videos through that window, as long as it doesn't get too dusty. On the back end here, I have my dust port, and this whole piece here, you see it here, you see it here. This is all 3D printed. This is ABS. It was done on my DaVinci 1.0. It's a pretty crappy print, I have to say, because it was printed on my DaVinci. If it was printed on my new Ender, this would look much better. And I would have printed it in PLA, not ABS, because I don't like making plastic waste as much as possible. Not good for the environment. Also thought it would be a good idea to highlight, you know, the brand of the machine and everything. You gotta celebrate this. This is a cool design, you know? Not just what I'm working on, I mean the whole thing. And the other key, and this is something that has been mentioned a lot in the forums, is that the base of this is HDPE. UHMW is also a suitable plastic. I mean, an acetal like Delrin would also be a good choice, albeit very expensive for something this big. I ordered this off of McMaster. That's a terrible idea because they ship it freight and that costs a lot of money, so I probably would have spent about the same on Delrin. Or they would have shipped that freight. And it would have cost even more. I actually still need to trim back this window. I'm going to take a flush trim router bit and fit the contour that's in the bottom of the sled. It mates up better with the dust collection system. You can't really see it. All that, no, you can't see that at all. But I'll flush trim cut all that. It will allow the dust to flow better up into the chute because I'm planning, the way that I kind of thought the flow would work, I haven't actually witnessed how this works in person. But the dust will fall down because you have to remember on the Maslow, this is sitting like this, not flat like we're looking at it on the table. So gravity would cause the sawdust to come down and then it would pull it up from there. Not sure if that's actually how this works. That was just a guesstimate. Let's talk spindle clamps for a second because this is a super difficult topic for this particular setup. I machined mine out of 3/4 aluminum because I work in a machine shop and it was easy for me to do. I realized that a lot of people do not have the resources for this. The only other version of spindle clamp I've seen on the forums that works well are 3D printed ones. People have tried to make wood ones. That was actually my original plan for it. But they just seem to crack, they seem to fail, and from a safety standpoint, you can't have a spindle clamp failing while a router has that, or while the CNC has the router in the wood, because that could fly off, that could start dangling. You could, worst case scenario, you smash your tool on the floor, you smash your router on the floor, something like that. Worst case scenario, it flies off while you're next to it and you get injured. So no, we're not screwing around with this. Safety is still my #1 concern here. I'm starting to go through the process of setting up kits, and in doing that, I will try to figure out what the best way is to get people spindle clamps that's not like super expensive. Because really, I want people to have a well-performing machine. In addition to the 3D printed version of the dust chute, it became pretty clear to me very early on in the development process, not everybody has access to a 3D printer, not everybody has a friend who has a 3D printer. So I needed to come up with a method that would make those people be able to get up and running without needing to even spend $200 on an ender or something like that. You know, the Maslow is supposed to be a low-cost machine. That's one of the tenets of the design, and I like to carry that through my own design. So I tried to come up with a decent way to solve that, and the community actually really helped in a lot here and helped me come up with a plywood version of it. And that has a little less flow than this setup, unfortunately, just from the dimensions of it, at least from what I've calculated. This is all theoretical here. But it at least gives those people an option to make themselves their own dust chute, even if they don't have a 3D printer, because, again, not everybody has a 3D printer. Maybe someday in the future, that'd be a really cool thing, but until that day. So, if you look at the Fusion 360 file for this, the other thing to note is that it has in the design all of the hole locations for all 3 of the major triangular kinematic systems. That includes the linkage, the 45-degree linkage system that I've got over here. That's my personal preference. We'll get into that later. It also includes the top mount version, which only has 2 holes up here. That one works pretty well as well, and it also has the hole pattern for the ring system, which is the most popular one at this point. So I went with a trapezoidal lead screw here. None other reason than really cost. This whole linear guide system was a kit that I bought off of AliExpress. You can find them on Amazon and a couple other of the usual suspects. eBay, I believe, has quite a few options that ship from the US if you're from the States. But I chose to do a trapezoidal lead screw with a brass nut just for the sake of cost. This whole system was 15 bucks, I think, on AliExpress. So really cheap. The US versions I think are like $20, $25. I'd have to check that though. It has significantly less backlash than what we see here and what we see here, because the other thing to factor in is this also serves as a lever and rotates when it's under load, which it's a CNC router, it's under load. So the trapezoidal lead screw is better at transferring those loads. It doesn't have anywhere near the same level of backlash, so what we should see from this is really good positioning. And the other thing that I'm really looking forward to is the pitch of this is significantly more aggressive than the pitch on the router base from Rigid, which means the Z-axis is going to move faster, and that's travel speed is one of the Maslow's weaknesses in every direction, but if we can at least speed up Z, that'll help if we're trying to do drilling or anything like that, because if you presently tried to do a full depth drill, you burn the wood because the feed speed is so slow. This lead screw, I forget what the pitch is off the top of my head. It's in all of the forum discussions, so definitely check out that thread when you get a chance. Unfortunately, again, it's like 500 posts, so when I say that, Maybe I'll put that in the comments. Maybe that'll help. So yeah, trapezoidal lead screw gives us more feed speed. The other thing is that I'm switching over to a timing belt setup here. I've got this is the original servo motor for the Z-Axis. And I've got that on a plate that will go back here. And then I actually bought a whole different set of timing belt pulleys to test out different gear ratios here to see just how fast I can move this whole assembly with this motor without stalling it. So hopefully it's like really fast, but the router is kind of heavy, so I don't know about that. Maybe when I switch over to a proper CNC spindle, that will change and it will be lighter, so it'll be easier to move. Not entirely sure. I'll cross that bridge when I get to it. I also designed a new bracket for this. When I talk about hardware kits, this would be one of the parts that's in there because this is not the stock one. I slotted it so that you could tension this whole thing, although after mounting this motor up to it, I realized that these two slots here are pretty much useless. Like, I guess you could get a wrench in there, but you have to factor there's these two gussets in the way. This is why you fully develop things before you publicly release them. But that being said, it's actually really fantastic to see that the community has taken off with this so much. And it was really funny to me to see that people ended up building functioning Z-Axis setups before I finished mine. And they got really good results with it, which is part of the reason that I have a good amount of confidence in the system to begin with. So yeah, to sum this all up, this is my design to kind of help fix some of the Z-Axis problems. There's definitely some things that I need to resolve with it still, and I'm still working on trying to support this issue with the community, trying to make sure that I always have NC files available for people so that they can cut out the most recent design. I'm also currently working on the DXFs, and I'm working on the PDF templates for people that want to cut this by hand, because as much as I designed this all to be CNC cut, anybody with a bandsaw and half a brain in a shop can cut this out. So it's not that hard to do by hand. You just have to be accurate to make sure that your spacing for the center line of the router stays in line with the spine here. That's kind of like one of the most crucial dimensions there. And because the relationship of the router to the linkage system is very important, and the router needs to be centered on those if you want to have good accuracy in the XY direction on this machine. So yeah, that's kind of been my development on this. Again, if you want more details about this, feel free to read the thread. I know it's a novel, so you don't have to. You can skim it, go look through, look at the pretty pictures. I know that's what I do half the time. But that's mostly just because the people on the forums are smarter than me, and when they go off on some engineering topics, I'm just left in the weeds. It's interesting to read the stuff, but sometimes I'm feeling like I'm not following it all that well, which is fine. I'm an operator. I'm just doing what I can to contribute to this project. I'd like to get more Maslow videos out, but right now I'm still in the process of trying to get stuff done on the house. And actually, the next series that we're getting into isn't even related to the Maslow at all. So those of you that like working on cars, you're going to like it. Those of you that only want to see the CNCs, I'm terribly sorry, but we will be getting back to the Maslow this winter. So thanks for watching. I'm actually surprised if you were interested enough to stay to watch the end of this, because I feel like I was probably just rambling this whole time. But like the video if you liked, leave a comment down below if you have any feedback you'd like to give or have any questions about the setup. And I'll see you guys all next time.